Let's check this guy out right here. We have a Czech who enters a highway driving at 60 miles an hour, and then a car, he enters the highway at the same time, in the same place at 8 minutes later, and drives at 73 miles per hour in the same direction. So from the time that the car enters the highway, how long will it take the car to pass the truck here? All right, so I put these two arrows right here to indicate that we have our truck right here, and then we'll say this is our car. All right, and so we know something about the speed of both of these guys. We know that the truck has a speed of 60 miles per hour, and then we also know that the car is traveling faster at 73 miles per hour, which would make sense that over time the car should catch up to the truck, and that's why we have the question right here. How long will it take the car to pass the truck here? So the truck will be somewhere up here. The car is going to start driving, and at some point over here, they're going to intersect, and the car is going to pass them up and say, "See ya, buddy. Catch you later." All right. So how is this going to work here? Well, this is really a practical formula that we use anytime that we're dealing with things that are moving and distance and time, and that is distance equals rate multiplied by time. And so we're gonna use that twice right here. The truck will have its own rate and time, and its car will have its own rate and time. All right, so let's check this out here. Let's just first write down the distance of the truck. So that's like a D with the subscript T. So the distance of the truck is its rate, 60 miles per hour, multiplied by its time. So check this out right here. Given that the car, or that the truck has an 8-minute head start, right? It gets to travel for 8 minutes, and then the car starts to travel. So because of that, the truck's time is actually going to be at T plus 8. Because if you think about it, the truck got an 8-minute head start. So it's going to travel, or it's going to be ahead of time of the car. And then if we think of the distance of the car, that's going to be rate times time. So again, that's just going to be 73 times T right there. Now, one thing to note, though, is that right now, if you look at this is 60 miles per hour. So really, this T right now is in hours, right? So if we want it to be in minutes, then we would just divide our time by 60. So I'm just going to divide this by 60. You say, why am I doing that? Well, because this is giving us the time in hours. The question is, how long will the car pass the truck? Well, it may not take hours. It's probably going to take in minutes, right? Because it tells us right here that it has an 8-minute head start. So really what this means is T plus 8 means an 8-hour head start, because this is in hours. But if you divide it by 60, now we're in minutes. So, all right, so check this out. This whole distance right here is dt. And this whole distance right here is dc. I think that we would agree that the dt, the distance of the truck, and the distance of the car, they're on the same path. And what we're interested in is that how long is it going to take for the truck to catch up to the truck. So really what I want to know is, when are these distances, when are they going to be the same? When is the truck and the car, when are they going to travel the same distance? Because once they've traveled the same distance, then that means that the car is going to pass them up right there, right? So really what we want to find out is, when is the distance of the truck equal to the distance of the car? That's what we're interested in. Well, check this out over here. On the right-hand side over here, we know that the distance of the truck is this guy, right? And we know that the distance of the car is that guy. So we can set the left side equal to the right side. Okay. So let's go ahead and maybe I'll just do this over here. So dt equals dc. So my dt is going to be, here, I'll just do it right here, is 60 times t plus 8 all over 60. And that's equal to 73 times t over 60. And basically what we want to know is, when once we solve for t, because t is our time, that's going to tell us how long it's going to take for the car to catch up to the truck. Now, check this out, y'all. See how they're both divided by 60? You know, like if I had 4 equals 4, and then I divide them both by 2, I would say 2 equals 2, right? But if I just get rid of those 2's right there, I still have 4 equals 4 or 2 equals 2. What I'm trying to say right now is that, look, since they both have divided by 60, let's just get rid of that right now. Let's just say, you know what, that's just going to create maybe a little more work than I need to. I mean, I don't know, maybe not, but like I'm just going to cross those guys out because they both are doing the same operation to both sides of an equation, which means that they're equal. So really I have, it's on this side, 60 times t, 60t, 60 times 8 plus 480 equals 73t. And probably that's a little easier than, like, you know, having 73rd over 60 and then having to multiply by its reciprocal. It's a lot easier right here, right? So I'm going to do two things right now. I'm going to subtract 73 on both sides. Actually, no, let's not do that right there. Let's just move the 60t over here. So let's just move that over. So minus 60t. So I have 480 equals 13t. And then I divide both sides by 13. And I'm probably going to get some kind of decimal there. I'm not thinking that that goes into nice. So let's see, divide by 13. Yeah, 36.92. So it's going to take 36.92 minutes. Let's go back up here. Let's do it around. How long will it take to pass the truck? It didn't say anything about rounding. I think maybe in the answer in this one, like it wanted you to round. So it's going to be 36.92 minutes or approximately 37 minutes then.